Today, we're going to talk about a single book that did way more than just propose a new model of the cosmos. It lit the fuse on a revolution that completely reshaped science as we know it. I'm talking about Nicolaus Copernicus's On the Revolutions of the Heavenly Spheres. So, how did one book do all that? Let's dive in. When Copernicus wrote these words, he was describing what astronomy looked like in his day. And he did not hold back. He saw the theories of his time not as this beautiful, coherent picture of the universe, but, well, as a total mess. A jumble of mismatched parts, he said, stitched together into something unnatural, a monster.
So what was this monster he was talking about? Well, for something like 1,400 years, the entire Western world just accepted the geocentric model. The idea that Earth is at the center of absolutely everything. But by the 1500s, that model was really starting to fall apart. It was in a full-blown crisis because it just wasn't working anymore.
To keep the Earth-centered model alive, astronomers had to come up with these incredibly complicated fixes. Just try to picture this. A planet is moving in a small circle, but that small circle is also moving along a much bigger circle around the Earth. That little circle on a circle is called an epicycle. It was this dizzying system of wheels within wheels. A real masterpiece of patchwork. But it just wasn't elegant. It wasn't convincing anyone anymore.
Yeah, the problems are just getting way too hard to ignore. Get this, astronomers couldn't even agree on the actual length of a year. They were all using different, contradictory methods. And all these complicated fixes, they went against this core belief, held since the ancient Greeks, that everything in the heavens should move in perfect, uniform circles, to reflect divine perfection. The whole system, as Copernicus so perfectly put it, just failed to show the structure of the universe and the true symmetry of its parts.
So Copernicus looked at this mess and decided the problem wasn't the patches, it was the whole foundation. His solution was honestly breathtakingly simple and at the same time profoundly radical. He moved the center of the universe. He basically asked this revolutionary question: what if all the strange, complicated movements we see up in the sky, the planets slowing down, stopping, even going backward, what if those things aren't actually happening out there? What if they're just an illusion, created by the fact that we're moving? And bam! By putting the sun smack in the middle, the entire solar system just clicked into place. All of a sudden, the order of the planets, the size of their orbits, how fast they moved, it all made perfect, logical sense. It revealed what he called a marvelous symmetry of the universe, a kind of harmonious linkage that the old, clunky model could never, ever achieve. This idea, of course, is what we call heliocentrism. And it wasn't just a new diagram, this was a complete reordering of reality. It demoted Earth from its special place at the center of all creation to just another planet, circling the sun with all the others. See, the real power of the heliocentric model was that it didn't just describe what was happening in the heavens, it explained it. All these weird phenomena that needed messy fixes in the old model suddenly became simple, natural consequences of the new one. Okay, let's take the biggest puzzle of them all: retrograde motion. For thousands of years, people were totally baffled by this. Why would a planet like Mars just be cruising along, then slow down, go backward for a few months, and then continue on its way? How is that even possible?
Copernicus's model gives us this beautifully simple answer. Think about it like you're in a car on the highway. You're in a faster inner lane. As you pass a slower car in the outer lane, for a moment, that car will look like it's moving backward, right? Relative to you and the distant trees. It's the exact same thing in the solar system. Earth is on a faster inner track, and when it laps an outer planet like Mars, it creates the illusion that Mars is moving backward.
So here's the crucial point. In Copernicus's own words, that weird backward motion isn't a real movement of the planet at all. It's just a reflection of Earth's own movement. That monster everyone was trying to explain was basically just a phantom, created by our own mistaken belief that we were standing still. Now, it's really important to get this. Copernicus didn't just invent this idea out of thin air. He was a brilliant scholar, he knew his history, and what he was actually doing was reviving a very, very old concept. Almost 1,800 years before Copernicus, an ancient Greek astronomer named Aristarchus of Samos actually proposed that the Earth revolved around the sun. But the idea, it just never caught on. It was totally eclipsed by Ptolemy's Earth-centered system. So what Copernicus did, and this is the key, is he took that ancient seed of an idea and for the first time ever built a complete, predictive, mathematical framework around it. He turned a philosophical thought into a working scientific model. The publication of De Revolutionibus back in 1543 is often called the starting pistol for the scientific revolution. But here's the thing, a revolution like this doesn't happen overnight. Copernicus's work was only the beginning.
Because, of course, while it was totally revolutionary, the Copernican model wasn't perfect, not by a long shot. Its biggest flaw was that Copernicus, who was a man of his time, still held on to that ancient belief in perfect circular orbits. You know, the circle being the most divine, perfect shape. But we now know planets move in ellipses, so his model still needed some little tweaks and couldn't perfectly predict where the planets would be.
So here's how it all came together. You can really think of it in 3 big steps. First, Copernicus provided the radical new model. Then, decades later, Galileo Galilei used his newfangled telescope to find the first observational proof, things like seeing the phases of Venus, which only made sense if it circled the sun. And finally, Johannes Kepler came along and figured out the correct mechanics. He discovered the elliptical orbits that made the whole system work perfectly.
But none of that later work, not Galileo's, not Kepler's, would have been possible without this book. Copernicus took that first incredibly difficult step. He dared to challenge 1,400 years of scientific consensus and gave us a framework that, yeah, it was imperfect, but it pointed all the future scientists in the right direction. He literally gave them a new universe to explore.
And that brings us to a final, really interesting thought. The whole debate that Copernicus started, it wasn't just about what was at the center of the universe. It was about the very goal of science itself. For centuries, a lot of people thought astronomy should just save the appearances, basically create models that predict what we see without really claiming that's how things are. But Copernicus argued for more. He wanted a model that wasn't just useful, but true. So, what do you think? What's the ultimate purpose of a scientific theory? It's a question we are, believe it or not, still grappling with today.